Hello everyone. Um, so recently I've met a lot of clients or other cases where constipation and gut related issues have been very high. So I thought I should make a video on gut related issues, majorly colon related issues, the bowel movements and things like that. The major focus of this video will be bowel movements, but before I get there, I would like to cover some basics about the gut. Okay, so to start with, what is the gut? The gastrointestinal tract. The gastrointestinal tract is about a 30-foot, you can call it like a super highway. It is like the trunk of the tree, the center part of the tree, and then there are lots of branches like the tree trunk where the heart stems out, and then the kidney stems out and all that. But then on this superhighway there are no exits. It is just one path in and one path out. So what is the gut? The gut consists of, let's say, a long tunnel which is about 30 feet, and right from the mouth to the anus is called the gut. The upper digestive tract, and so the food that we eat, the food that we consume, basically goes through this uh, canal, and then it gets processed along the way, and then it is excreted through the anus. Okay, so this is the process. Now the upper digestive tract consists of our mouth, the esophagus, and then the stomach, and then the liver, and then your small intestine's upper portion, which is called the duodenum, which is where actually uh, the absorption process starts. Okay, so what happens? The food enters the mouth, and then uh, some amount of digestion happens there because of the salivary glands. The Before that, even your sense organs basically look at the food, and a signal is already sent to your brain that the food has arrived, and the saliva is produced, and then some amount of digestion happens in the saliva, through the saliva in the mouth, and then it goes through the esophagus, and then next it enters the stomach. In the stomach, you have the hydrochloric acid that gets produced, and this hydrochloric acid maintains the right pH to keep our stomach balanced, or the body's digestion process balanced. See, if you see, um, the foreign objects like food basically enters only through our mouth, and there is no connection to our cells, human cells, directly. So what happens is, it needs a lot of, what do you say, sterilization and many of those things. It needs to be really cautious about what is actually coming in, which can even harm the body. So this gut has a lot of germs. It is called the microbiomes, and gut has a lot of it. So you can say that about, if you have one human cell, we have about 10 cells of germs. You can call it the bacteria, pathogens, whatever. So these germs are about 10 to 1. So they are we as humans are predominantly germs more than human. So today we have a very sad state where we are basically getting scared of germs like COVID. But to be very honest, without germs we cannot survive, because they are the ones protecting our body in many ways. And if we maintain a symbiotic relationship with these germs, then they in turn help us, and we get the benefit of health. Anyway, so in the stomach, there is a right pH value that is maintained, which is acidic, and then protein digestion actually happens there. Pepsin gets produced, and then protein digestion happens here. So the food itself has a certain pH value, and then the hydrochloric acid gets mixed with that, and then the entire food becomes acidic. So this food is called in this process, at this stage, the food that is in this stage of digestion is called chyme. CHYME, chyme. And then beyond this, we have the involvement of the small intestine, the liver, the pancreas, and all those things. So when in the duodenum, the acidic chyme cannot enter the duodenum. So what typically happens is, before the chyme even comes to the duodenum basically secretes a hormone. I think it's an enzyme. It secretes an enzyme which triggers the gallbladder to release the bile juice. The gallbladder is like a assistant to the liver. The liver basically produces the alkaline bile juice, and this bile is like a turpentine which kind of thins down the paint. Its major job is to basically dissolve or thin down or break down the fat from the food into fatty acids and all that. So this gallbladder stores the bile juice which and produces it to the duodenum for the digestion process. But for that to happen, the duodenum basically secretes its own enzyme, and then all this process happens. Now, we told that the duodenum cannot expect or will not be able to handle acidic chyme. So what happens is the pancreas produces something called sodium buffers and alkaline liquid, which basically neutralizes the acid to the extent of what the hydrochloric acid would have produced, the acidity that the hydrochloric acid brought in. To that extent, the pancreas produces this alkaline sodium buffers which neutralizes it. And then this is where the major breaking down process in the duodenum and the absorption process also happens. So here the potency of the hydrochloric acid is extremely important. So like I said, if the hydrochloric acid is maintaining the right pH value, provided the lifestyle and everything is okay, then the pH value of the hydrochloric acid will actually be good. So why is the pH value of this is very important? Because when this external foods enter the internal environment of our body, it will contain a lot of invaders, it will contain a lot of viruses and many of those things, and then it is very important for all of these things to be checked in the hydrochloric acid. So the hydrochloric acid basically kills many of those things even before it reaches our own internal organs. But if the potency of the hydrochloric acid is not very good, then there is a good chance for bad. I cannot say it's bad, but then the germs which basically are like parasites, or which we really don't have symbiotic relationship with. There is no give and take. It is only basically take. So those kinds of germs make this body their home, and once they start invading the body, there is a good chance that the symbiotic bacteria, which is helpful for our well-being, also gets reduced because of the wrong environment or wrong gut conditions in our body. And what also happens is this causes bloating, this causes a lot of fermentation, improper absorption of food into the body and all that. So one thing that you'll have to remember is these microbiomes or the symbiotic bacteria that we have in our body is very important, because they are the ones that ingests the food that comes into the stomach, that comes into the gut in the small intestine majorly, and then they are the ones that break down this food into molecules, and then those molecules basically go into our bloodstream. So if the flora is not in the good condition in our gut, and we have other germs which are not very helpful to our body, then you can expect that the gut environment is also very unhealthy, and the food will also not be able to get absorbed properly, and then it will just go outside the body. It will just get eliminated from the body um, without the nutrients getting absorbed or getting broken down and all that. So bloating, constipations. So in fact, many of the issues related to the brain, nervous system, and many of these things are also related to the gut, because the gut-brain connection is extremely important for our well-being. Okay, so what else? So, like I said, the liver is a very busy organ. Um, the major function of the liver is to um, is it's like an inspector. It basically keeps a check of the toxins that are in the blood, because how did what is this when the food basically gets broken down into molecules, what happens in the small intestine, that is the upper part of the small intestine, the fat digestion happens, which is the bile comes and then breaks down the fat and all those things, and then into smaller chunks, fatty acids, and then other food also gets broken down into molecules. So if you can imagine that our food gets broken down into many of these simple sugars and simple salts that are in our periodic table, like sodium, potassium, zinc, and many of those things. So to that level, the molecules are sent inside the bloodstream. So we have a we have a thin layer called epithelial layer, which is more like a cheesecloth in the intestine, and then which is where this protects the body, this protects our blood from anything and everything reaching to the bloodstream. So there is a lot of filtration process that happens there, and then these molecules get into the bloodstream, and then this blood goes to the liver. So the liver inspects this blood for toxins, because from the liver it goes to the heart and other critical organs. From the heart it goes to the critical organs. So um, so the liver, the job of the liver is to also do a lot more other activities, the like I said, it's a very busy organ. It also synthesizes hormones and then proteins, and then it also, it's a factory for bile juice. So right, so this is about the liver. And in the small intestine, there is something called small hair-like structures called the villi, and this villi helps in that absorption into the bloodstream. And typically, when we have lifestyle issues and all that, so this hair-like structures also gets affected, and the absorption also becomes a big challenge, right? So what else? Yeah, and so after that, all we are left is a mass of food particles, which has to now travel down to the rest of the small intestine, where absorption continues to happen, and then it goes to the large intestine. In the large intestine, we have three portions. One is something like the ascending colon, and then we have the transverse colon, and then we have a descending colon, and then we have I think the rectum, and then we have the anus, right? So what happens from the small intestine? There is a the food goes into the large intestine, which is typically responsible for the bulk of our food, the solid part of our food. So here also in the ascending part of the colon, which is more of a there is a climb, there is an upper climb for the food to actually go. So this colon doesn't really have the capacity to actually carry liquids like your juices and all those things. So I'll come to the, when I speak about the diet, I'll talk about the juices. So in this ascending climb, also there's a lot of absorption that is happening, and the actual bowel creation basically starts from the transverse colon. So what happens is this, in all these, in the entire gut, peristalsis action on the muscular contraction and expansion is extremely important for anything, or for the food to move from one place to the other place, right? So okay, now coming to the small intestine. See, the small intestine, I told that there is a first part of the small intestine is called the duodenum, and there is a second half of the small intestine, and from the small intestine the chyme basically goes into the large intestine, right? So what happens in the small intestine? In the small intestine, uh, lots of mixing happens, absorption happens, and what kind of mixing we are speaking about? We are mixing chyme itself, which is the food that we ate. So here hydrochloric acid was mixed, and then we have the pancreatic juices that were mixed, right? So here exactly that mixing happens. So now we have the hydrochloric acid, and then the chyme, and then we are going to have the pancreatic juices, and then we have a bile. So we have four things that are going to be mixed in the small intestine. Okay, and how are these things going to be mixed? Okay, if we have a container at home, or let's say we are making sambar or rasam or something, we put all of these things, and then we have enough space to actually uh, stir the ladle inside the container and then mix everything. Now, how is the small intestine? The small intestine is like this. Okay, we have, let's say, like this. So there is a constriction here, there's an expansion here, and then again something like this starts. It's like a caterpillar, if you've seen the caterpillar. So you have another one like this. So we have a series of, this is the shape, right? And then that is in the form of a coil and all that. So here, if mixing has to happen, there has to be a process to mix, and there has to be a way to mix it, right? So it's a beautiful way of, it's the beautiful way, design is extremely beautiful. So what happens now? Let's say in the first portion there is chyme, in the second portion also there is chyme. Now what happens is, there is, so here in the, before all these things, when something comes into a certain area, now if that intestine, if that portion was actually like this, it stretches like this. So what happens, if it is stretching, this food is also coming into contact with the mucosal lining here. So it is also mixing the mucosal fluids, or the mucus from here. So why this mucus is very important? Because it has to become more, and this mucus is, when you have a lot of fiber, the mucus also helps in making this like a jelly. So this mucus also gets mixed with the chyme. So we have the bile, right? I've just written it down here. We have the bile, the chyme, just so that I don't forget, right? And then we have the pancreatic juices, right? What are these pancreatic juices doing here? They are basically digesting the proteins, the carbohydrates, and then the lipids, right? And the bile is emulsifying the fats and then helping us digest the fats better. And then we have the fluids in the intestine, which is already present there. And then we have this mucus, right? All these are getting mixed up. So the way it gets mixed up is, first of all, there's absorption is also happening. So this contact of this chyme, or this mass, is extremely important to touch these surfaces, because here absorption is also happening from this side, rather from this wall, the absorption is also happening. So here it is extremely important. But the body also has to absorb other things also, which are basically getting produced, like bile and pancreas. So it's a chemical digestion also that is happening here, right? Now there is a constriction here, and there is one here. So what happens is, in each there is a process called segmentation that happens. So what happens? This presses like this. This also presses like this. So when this presses, the upper portion basically opens up, and the mass that is on the upper portion goes into the that thing of the neck on the which is on top, and then the bottom one goes down. So essentially the top portion and the bottom, basically this just goes inside this, and then sort of the mixing happens there. Along with this, they are also having a peristalsis pushing action to go into the larger intestine towards the anus. So this is happening in the small intestine, mixing, basically mixing like this, and then getting absorbed. So mixing is a major process of the small intestine, and basically they're getting mixed up and then they're getting absorbed. Parallelly, they are also slowly moving into the larger intestine. So this is what is happening in the smaller intestine. So in the small intestine, apart from segmentation, which is the mixing part, there is also something called peristalsis action, because the fecal matter has to also move into the large intestine, right? Things have to keep moving on, so there has to be the pushing action. So this peristalsis, this is called a peristalsis action. It's like a worm-like movement, which actually keeps, there is something that pushes, there is something that relaxes. So something has to contract, push. So if it is pushing, the bottom portion has to relax. Now from here, again the contraction happens and then the relaxation. So like this, the pushing keeps happening. It's a muscular movement. So in general, when the food is basically moving like this, the peristalsis action is basically happening, right? So that is the peristalsis action. So so what are the typical things that plays a role in this peristalsis action? So typically when the food moves into the small intestine, now there is a stretch of the small intestine. So it is basically getting a signal that I have to basically work on things. So that is a stretch movement. And the second thing is our parasympathetic nervous system, which is not in our control, and then the involuntary and then voluntary nervous system, the parasympathetic and sympathetic nervous system. So that comes into picture. And then we also have the irritants. So what are these irritants? Things like the nature of the type of food. So things like too much of fat in your food, lots of unwanted food particles, which are like allergens, things like gluten, things like dairy, and many of these things, or meat for that matter, or lots of chemicals, drugs in the sense medication. Many of these things are also called irritants of the food. So these things, what happens, these irritants, when it comes in touch, when the body comes in, when the food comes in touch with the when the chyme comes in touch with the surfaces, the mucosal lining will basically get irritated. So when this gets irritated, it just wants to just keep pushing it. See, many times we have noticed, I have heard people telling, if I don't have my cup of coffee, I will not be able to pass my bowel movements. So many of these things, right? They eat the wrong foods, or they drink the wrong things, and then or they want something in the stomach to basically pass bowel movements, because there is no gut brain connection is not very strong. Whatever it is, the reasons could be plenty, but it is like only when there is something coming in, there is something going out, right? So they always want something to keep pushing before something actually comes out. So there is no automatic peristalsis action. It's not very efficient. So some of these irritants in the food can also make the peristalsis action happen. So you should also notice that sometimes when we are not eating food also, we can go and then pass motions. So those are also something like some peristalsis actions, or that pushing movement, which is also happening during the fasting stage, which is when we are not eating. So what does this do? This is what you say, it's like a loop kind of movement, a process what it does is, from the duodenum, it is constantly doing peristalsis action of pushing. Whether there is food or there is no food, it just keeps doing every 3 hours. There is a constantly that cycle that just keeps happening. So what does it bring along with it? Maybe in the first stage, when the food moved on, there were things did not completely move. So there could be undigested food. Maybe that took a little delay in the digestion process, or maybe you ate something again, something little again. So something which basically did not go in that major cycle, regular cycle. Well, all this undigested food particles, then the dead bacteria or dead cells, some of this toxins. What else could there be? Let's say basically any food residue, right? Any food residue that did not, that is still there, it will just keep bringing it. Sometimes body won't handle things, like sometimes we end up eating some coin or something like that. Children end up eating some coin or something. They'll say, okay, it will get anyway discharged when they when they pass bowel movements, they say, right? For example, when my child was little, she actually swallowed her own tooth, and then when she passed bowel movements, and then at that time we also saw the tooth coming out. So these are things that body does not digest. So these things also basically come out, right? Maybe in the first stage they don't come out, and then over a period of time, the body, so every 3 hours there is a movement that is constantly happening, and then they come out. So in the small intestine, these two processes majorly happen, the mixing and the peristalsis movement. And then the third thing that actually happens is, you have now how does these feces move from the small intestine to the large intestine? There is a door kind of thing, or a valve, you can call it a muzzle, valve, which is basically a muzzle. So how does this muzzle know when I should open up? Usually it is basically shut like this. It is closed. So let's say this is the small intestine, and then this is the large intestine. So it has to open up for things to go from here to the large intestine. In the end of the large intestine, rather in the beginning of the large intestine, you have this appendix also here, which is the one that constantly keep, we have cases where they have an pain or something like that, and then there are cases where they've removed the appendix for no reason. Anyway, so this is the appendix, which is also a lymphatic node, a big lymphatic node, which sort of collects the toxins from these areas, and then it feeds to the lymphatic system. Anyway, so from the small intestine, so how does this know that it has to open? There are two things. This basically gets the signal to relax and open when actually food comes into the stomach. When food comes into the stomach, gastrin is produced, and that production of gastrin itself is enough. The signals come here, and then it basically relaxes the gastrin also. It not just the digestion process in the stomach, not the digestion process, the breaking down process in the stomach also happens, and then this also is relaxing. Sometimes what happens is, when you actually eat food, you also feel like passing bowel movements, right? So maybe especially when the large intestine is also full, or when there are irritants, or lots of other issues are also happening. What happens? This is basically relaxed, and then things basically just go into the large intestine, and things are also coming out, right? So this is relaxed. What also relaxes this is, now in the food, if there is a lot of irritants, if there is what else? Basically, if there are things where the body thinks it's not good for it, it will send the signal to the brain, and the brain will take a decision to basically relax this. Okay, so even though so there are two things that relaxes, not just the gastrin, but also the irritants. Because let's say on the way also, at any point in time, the body can sense that I am getting threat, I am vulnerable. So I will basically work with the brain. I'll send a signal to the brain to basically relax this, because sometimes you may have loose motions because you ate something spicy, and then you just want to expel, the body just wants to expel it out. You went and ate some bad food somewhere, and then you're basically going to get prone to loose motions. So this is when this valve also opens. So these are the three things that happens in the small intestine. So majorly absorption, and absorption is through this villi that I spoke about into the bloodstream. They get absorbed, and then the movement into the large intestine, and then once this opens and all that, the valve opens, it goes into the large intestine, right? So this is what typically happens. So coming to the large intestine, so from the we spoke about the small intestine already. So from the small intestine, when it comes to the large intestine, in the large intestine, the feces are now traveling upwards. We have the ascending colon, and then we have the transverse colon. It comes like this. Okay, so we have the ascending colon, then we have the transverse colon, then we have the descending colon, then we have the sigmoid colon, and then we have the rectum. Okay, so in this ascending colon, again absorption is happening. So typically, what are the things that actually causes movement? So here also there is absorption happening. So here there is a stretch. When the feces come in, these things stretch like this. So that is also basically giving a reason to move forward. And then we also have the irritants. That is, the food can contain particles that can irritate the mucosal lining, and then it can go up. And then what can also push and then move it forward is when the food comes into the stomach, the same gastrin can also give signals to all these things to basically move it, because it has already given the signal to the small intestine, I told you, right, to that valve. So if food is actually coming inside this entire small intestine, large intestine and all that, the space also has to get created for, if this is already full, or if there is something that is already inside this channel, it has to actually flow out, unless we have some issues where things are basically going to get crowded, it still has to basically come out. So in an ideal situation, the gastrin also gives a stimulus to this to basically push it forward. So from the ascending colon it goes up, and then in the transverse colon again it is pushing. So this push in the large intestine is so huge that one of this contraction and relaxation, which is the peristalsis action, can push the feces up to 20 centimeters. It is that huge, right? And our colon, they say, is the almost the length of our body, in which is in the form of coiled structures like this. So it is that big. So 20 centimeters it actually moves, and then it goes into the descending colon. So this is pretty much where all of these things are happening. So this peristalsis action, or this pushing action, can happen up to 3 to 5 times a day. So when this is happening, it can happen during the when you ingest food. It can also happen when you are fasting. So depending on when the body thinks that it has to move, anytime you can pass bowel movements. Ideally at least 2 times you'll have to pass, because if you're having 2 meals a day, then at least 2 times it's best to pass. So if things are not actually happening in that rate, uh, a lot more has to happen to make this entire process better. So gastrin is also important. And see, what also happens is when the body decides at any point in time, at the stomach level, or at the small intestine level, or at the large intestine level, there are always receptors which are basically sending signals to the brain depending on the kind of feces that you have, the quality of feces. It is always sending the signal to the brain to basically hasten the defecation process or this release process, because it doesn't want to constantly be in touch with these irritants in the food. So that is why many people with the irritable bowel syndrome and all that, they have the mucosal lining, which is already very what do you say, um, sensitive. It has already become very sensitive, so it will always keep pushing until that actually mucosal lining heals. And in fact it can happen anytime in the gut, because if the body is constantly sensing a threat, right, it is obviously going to keep pushing all the time. Especially those people, when they start eating, they will always want to go and then defecate. So so in there is so much of I'm just giving a very summary view of this entire thing, but then if you go into the detailed view, there are every single, there are so many signals that are actually happen even to contract and relax, because something has to push, something has to pull, something has to push, something has to push. So like this, for this movement itself, there is so much of anatomy involved. There are nerves involved. There is brain involved. There are hormones involved, and something is producing hormones. There is so much of coordination happening for this uh, pooping process to happen, right? We think it's just simple. If I It will just push. It is like just throwing something down your throat, and then it is just going to flow out. It is not. There is so much of intelligence involved in this entire process, that there can be so many factors that can actually go wrong in this superhighway, and there is no exit at all. There is one way in and another way out, one way out. So um, there is no way anything can escape this path, and there is absolutely no exits, and the only exit is absorption through that layers, the walls, and then from the walls it basically gets into the bloodstream, and the bloodstream itself has to take the nutrition to the entire um, body. So yeah, so it comes to the transverse colon, from the transverse colon, and then it comes to the descending colon, and then it comes to the rectum. In the rectum, see this rectum, right? It's like a reservoir, right? It's like a reservoir, like a storage thing. So this rectum, they say that when you actually feel that you have to poop, it can be about 20 milliliters of poop. I don't know why they call it milliliters and not in kgs, but then possibly because it's semi-solid or whatever. But the metric that is used for the feces is milliliter. So up to 20, if there is 20 milliliter, apparently you can feel the feces in the thing, and you feel like going and defecating. But then it is so stretchy that it can also accommodate up to 400 milliliters. And if it is hard, it can keep collecting and collecting and collecting and collecting, stretching and stretching and stretching. So imagine, they say that we can actually have 5 to 10 kgs of poop inside us if we are leading a lifestyle that is where we don't have a regular bowel movement. We can actually carry kgs and kgs. That is why when people go through a detox process, they lose 5 kgs very, very easily, right? The first 5 kgs, 7 kgs are very, very easy. Within few days, you can actually release this weight, because this is not fat. This is just the sheer weight of toxins in your body that can uh, help you reduce that weight. So it is that much, that important. So yeah, so this is the defecation process, and then from the rectum, in the rectum there are two valves, or they are called sphincters. So there is an inner sphincter and an outer sphincter. I'm not going into the medical terms here, so I'm just going to say inner sphincter, outer sphincter. So the inside sphincter, which is let's say this is the rectum, the inside sphincter, that is basically controlled by our involuntary muscles or the parasympathetic nervous system, and you don't have any control over that opening and closing of that. It is usually shut, but any of these brain signal coordinations and all that can basically open that. So that is the inner sphincter. And then there is an outer sphincter, outer anal sphincter is what it's called. And that is always tightly shut, because you don't want to keep peeing in your pants, right? In your panties or your underwear. So that is basically tightly shut. And um, so this internal anal sphincter, right? It is something that is controlled by the body. So when the body wants to push the feces out, it basically opens it up. It is controlled by the involuntary nervous system, or the Involuntary muscle. It's an involuntary muscle. Now, what happens? So, let's say the body is now wanting to release the poop, but you are not in a position to actually uh, go and visit the bathroom. So, this is where we have this is where the external anal sphincter comes into play. It is controlled by our voluntary um, nervous system, voluntary muscle. It's a voluntary muscle. So, it it is it is very closely associated with our brain, right? So it has a lot. So when you are actually sitting on the potty, that is when we know that we have to defecate, right? That is when the brain understands this, and then this is when that the valve actually opens. The external anal sphincter opens, and then the poop comes out. So there are so many things that are basically involved here for things to actually come out, right? It is um, right from the food entering to the stomach, to the quality of food that is entering the stomach, to the kind of potency of the hydrochloric acid, and right, all the receptors that are connecting to the brain. And in the rectum, there is a lot of signals that goes to the spinal cord. From the sigmoid colon and the rectum, there is a signal that goes to the spinal cord also, to do the contraction and the expansion, and then pushing action and all that. There is a spinal cord that is involved. So there are so many hormones that are involved. There are so many nerves that are involved. There are so many receptors that are involved. Brain is involved, right? And these muscles are involved to absorb. Blood is involved to actually collect it. And then there is a epithelial layer, or that thing that is basically filtering the essential nutrients into the blood. And then the passage of, or the movement from the mixing action in the small intestines, right? And then the peristalsis action in the small intestine, and then the valve that has to open, when that has to open. Then we have the large intestine, and then the absorption in the large intestine, and then the movement in the large intestine, the stretch action in the large intestine. So there is so much coordination in our body that is happening without our knowledge, for the defecation process or the feces to actually come out, right? So there could anything can go wrong in this superhighway, for you to be constipated, for you to be, let's say, having a delayed exit into the stomach itself could delay, and then not send it to the small intestine, because there are issues with the stomach muscles. There are issues with the hormones there for the release of chyme. And then there could be issues in the duodenum. There could be issues in the liver giving enough bile, or the potency of the hydrochloric acid there. So in the stomach issue. So here the liver, then the gallbladder. In many of my clients, there is no gallbladder, because they have, if you have a lot of fat that is ingested in the food, the gallbladder could collect potentially a lot of fat. And uh, so if the gallbladder has a lot of stones because of the enough fat in the food, the gallbladder has a lot of stones. So sorry, yeah. And many people have got it removed, right? So this absence of the gallbladder, or the potency of this bile, because the liver could be very tired from all the digesting process of heavy foods, and it could be tired, so the bile could not be potent, and the small intestines muscles. And then there could be a lot of tear in the small intestines epithelial layer, so things can actually, food particles can get into the bloodstream, and the bloodstream can think those are foreign invaders, and then they could attack. So you have allergens, you have allergic reactions that are happening, for, where the food is basically entering the bloodstream. So, and then the muscles could be weak, and then they may not be stretching properly, and then even if they are stretching, the peristalsis action is not happening properly. So for the peristalsis action, you need a lot of these receptors. The brain has to keep sending the push and the pull and contraction and relaxation signals, so that has to happen properly. And then you have to, all these valves have to open properly. For that valve has to, for the valve to relax and not relax, to relax and contract and all that, the stomach has to be proper, the stomach's contents and the gastrin hormone has to be proper, right, that has to be proper. And then in the large intestine, again, the we don't know what is the previous feces that are already sitting there in the walls, stuck to the walls in all these intestines, because there was no proper peristalsis, there was no proper hydration, so things are stuck to the wall, there is no proper space inside, it is all full, there is a lot of roadblocks, right? Even though they are pushing, things are actually not moving forward because the feces are really hard, right? There could be so much of coordination involved in actually things moving from one place to the other place, whether it is. And also in the large intestine, there is so much of bacteria which eats our food, which eats the feces, and then it produces a lot of gas. So if you're eating a lot of gassy foods, there are foods that are undigested food that can produce gas, and there are some foods like beans, cabbage and all that can produce gas, which are okay, those kinds of gas are okay. But then the other kinds of gases which are which cause the bloating kinds, from dairy and wheat and many of those other things, other irritants in the thing, so that those the flora inside the intestine should be okay, right? Otherwise they will get killed, and then things are there is a lot of bad parasites inside which are basically eating up, and then there's malnutrition, malabsorption happening. So there could be so much that is actually happening for the poop to get created and then passed down from inside and then go outside, rather outside the anus, right? So I think you can imagine that this is not a simple process. Pooping out is not a simple process. So um, so next I'm going to talk about specific questions that you all spoke about, so that I can actually cover them in all these. So now that you understood the process in the anatomy, as a part of the anatomy, when I address the questions, you should be able to understand what is exactly happening in this entire, where things are actually going wrong in this entire process, right?